September 15, 1940. Reich Ministry of Aviation, Berlin. Hermann Göring, Reichsmarschall of the Luftwaffe, walks through the marble corridors, clutching an intelligence report. His pale blue uniform, decorated with excessive decorations, creaks with each heavy step. In the conference room, his top aeronautical engineers wait nervously. "Gentlemen," Göring tosses the report onto the polished mahogany desk. "Our spies in America report that Hamilton Standard is developing a new propeller. Apparently, they believe they can create blades that automatically change angle during flight." Dr. Ernst Heinkel, designer of the He-111 and the revolutionary jet-powered He-178, examines the stolen technical drawings. His brows furrow in skepticism. "Herr Reichsmarschall, this is too ambitious. They propose a hydraulic mechanism inside the propeller hub that continuously adjusts the blade pitch. The complexity is absurd. The additional weight, the potential failures." Göring lights a Cuban cigar, blowing aromatic smoke around the room. "Let the Americans waste resources on complicated toys. Our fixed-pitch Messerschmitts already dominate the skies over Europe. Simplicity and reliability trump complexity every time." Major Adolf Galland, Luftwaffe ace with 67 confirmed victories, laughs at the table. "Americans always overcomplicate things. While they play with hydraulics, our pilots perfect the art of killing. A propeller doesn't win wars. Superior pilots win wars." Göring raises his glass of captured French cognac. "A toast, gentlemen, to permanent German superiority in the skies. Let the Americans spin their magic propellers. They will soon discover that physics and reality do not bow to the dreams of engineers." The room erupts in laughter and toasts. Outside, the autumn sun bathes Berlin in golden light, the city still untouched by the bombers to come. What they didn't know was that Frank Walker Caldwell, a 49-year-old Quaker engineer from Connecticut, had just solved a physics problem that would transform every American fighter jet into a 100-mile-per-hour killing machine. The sky was about to change hands. Hartford, Connecticut, Hamilton Standard Laboratories, January 1935. The problem was elegantly simple and frustratingly complex. Frank Caldwell, chief engineer at Hamilton Standard, the propeller division of United Aircraft, stared at the equations on the chalkboard that covered an entire wall of his laboratory. Physics was unforgiving. A propeller optimized for takeoff was terrible at cruising speed. A propeller designed for top speed made takeoff dangerously long. It was like trying to create a bicycle gear that worked equally well climbing hills and on flat ground. Frank, his assistant David Prince, a young MIT engineer, pointed to the calculations. "It's impossible. We'd need the blades to change angle during flight. Not just once, but constantly, adjusting to every change in speed, altitude, air density." Caldwell, a quiet man with wire-rimmed glasses and hands that trembled slightly from too much coffee, replied calmly, "Then let's do just that." "What? The pilot can't be manually adjusting. He's too busy trying not to die." "Automatic," Caldwell murmured, his eyes shining with the fever of discovery. "Fully automatic, hydraulics controlled by engine oil pressure." The concept was revolutionary and seemingly impossible. Inside the propeller hub, hydraulic cylinders would adjust the angle of each blade based on multiple variables: engine RPM, manifold pressure, airspeed, altitude. All this while spinning at 2,400 revolutions per minute, enduring centrifugal forces that would transform solid metal into distorted mass. The first prototypes were spectacular disasters. Prototype number 1 exploded on the test bench, its blades flying like deadly projectiles through the lab walls. Miraculously, no one died. Prototype number 2 stalled at maximum angle during a test flight. Test pilot Chuck Malone was only able to land because he had learned to fly gliders. The engine overheated and partially melted. Prototype number 3 ran for exactly 43 minutes before the hydraulic system leaked, covering the windshield with hot oil and temporarily blinding the pilot. The U.S. Navy, Hamilton Standard's main customer, was losing patience. "Caldwell," Admiral John Towers growled during a meeting in Washington, "we spent $3 million on this project." $3 million. Do you know how many conventional aircraft we could have bought with that? "Admiral," Caldwell replied, his hands shaking not from nerves, but from exhaustion after 72 hours without sleep, "give me 6 more months. If I fail, I will resign and personally pay for one of the destroyed prototypes." "You don't have that kind of money, Caldwell." "No, but I'm sure it works. The math is correct. It's just a matter of engineering." Towers looked at this thin, exhausted man who promised the impossible. 3 months, not a day more. Caldwell worked like a man possessed, 18, 20 hours a day. His wife, Margaret, would bring him meals that he forgot to eat. His assistants would collapse from exhaustion and be replaced by new shifts. The main problem was the governor, the brain of the system. How could we create a purely mechanical mechanism that could process multiple variables and make decisions thousands of times per minute? The solution came in a moment of exhaustion-induced clarity. Caldwell realized he didn't need a system that thought. He needed a system that reacted, pure physics, forces in balance, centrifugal weights that moved with the rotation, calibrated springs that resisted, oil pressure that amplified, each force balancing the others in a mechanical dance of absolute precision. March 27, 1935, prototype number 7, now called the hydromatic propeller, was installed in a Seversky P-35. Test pilot Jimmy Collins was visibly nervous. "Frank, if this thing blows up—" "It won't," Caldwell replied, though his hands were shaking more than usual. "The math is perfect." Collins started the engine. The propeller began to spin. Automatically, the blades adjusted to the takeoff angle. Collins didn't touch anything. He accelerated for takeoff. At 1,800 RPM, the blades adjusted again, biting into the air with maximum efficiency. The P-35 jumped off the runway in just 200 meters, half the normal distance. At cruising altitude, the blades adjusted for speed. Collins pushed the throttle to full throttle. The speedometer climbed. 218 DAF, 300 MAF, 320 MAF, 340 MAF. The same plane with the same engine was flying 95 miles per hour faster. "My God!" Collins yelled over the radio. "Frank, you did it! This thing is a rocket!" But when Collins landed and engineers examined the data, they discovered something disturbing. The system had worked too perfectly. The forces involved were greater than calculated. 3 more prototypes would be needed before it was ready for production. No one imagined that that imperfect test in Connecticut carried the seed of American air supremacy. Caldwell's propeller wasn't just an improvement. It was a revolution waiting to happen. December 14th, 1941, Clark Field, Philippines. 1 week after Pearl Harbor, Captain William Wild Bill Kelly of the 20th Pursuit Squadron watched helplessly as his base burned. 42 P-40 Warhawks, the pride of the U.S. Army Air Forces in the Pacific, lay destroyed on the runway. The Japanese Zeros had attacked with impunity, dancing around the American fighters like bees around sleepy bears. "Damn new propellers," he spat, kicking the wreckage of his own P-40, one of the few equipped with the first production hydromatic propellers. Too complicated, too heavy. His chief mechanic, Sergeant Tom Rodriguez, examined the wreckage. "Captain, it wasn't the propeller. We just didn't know how to use it. Pilots still fly as if they had fixed propellers. They don't trust the system." The official report of the Clarkfield disaster was brutal. The new Hamilton Standard Hydromatic propeller systems have demonstrated questionable reliability under combat conditions. Multiple failures have been reported. Pilots report slow response and unpredictable behavior. A return to manually controlled pitch propellers is recommended. Back in the United States, the newspapers were merciless. Miracle technology fails first real-life test. Chicago Tribune. Expensive propellers don't save American lives. New York Post. Frank Caldwell read the reports in his dark Hartford office. Each criticism was a knife to the heart, but something about the data didn't make sense. The propellers that failed weren't the latest versions. They were old models, hastily installed without proper training. He flew to Washington, marching uninvited into the office of General Henry Hap Arnold, commander of the Army Air Forces. "General, give me a chance to prove the system works. 1 squad. Proper training. The last propellers. If it fails, I take full responsibility." Arnold, a pragmatic man who understood both politics and war, considered. "Caldwell, we have P-38 Lightnings arriving in England. Brand new, not yet combat tested. If you can guarantee their propellers will work." "They won't just work, General. They'll make the Lightning the fastest fighter in the European theater. You have 1 month to prove it. 1 month. February 15th, 1943. Duxford, England. Headquarters, 55th Fighter Group. Major Thomas "Tommy" Lynch watched skeptically as Hamilton Standard technicians installed new Model 23E50 hydromatic propellers on his P-38 Lightnings. The propellers looked different, thicker at the hub, with hydraulic lines visible like veins in a muscular arm. A gentleman, Frank Caldwell, who had personally traveled to oversee the installation, addressed the assembled pilots. "Forget everything you know about propeller management. This system does the thinking for you. Your only job is to fly and shoot." Lieutenant Richard "Dick" Bong, the future American ace of aces, raised his hand. "Mr. Caldwell, what happens if the system fails in combat?" "There are 3 backup systems. If all fail, the propeller locks in a position that allows safe return. But in 2 years of testing, I've never seen them all fail." The real revelation came during the first familiarization flight. Tommy Lynch pushed the accelerator pedal of his Lightning. The Allison engines roared, but something was different, radically different. The acceleration pushed him back into the seat like never before. The speedometer soared wildly. 300 T mustu, 400 billion, 420 billion, 400 T vodil. "Jesus Christ!" Lynch yelled over the radio. "I'm doing 440, indicated at 25,000 feet." But the real magic happened when he pulled back on the stick for a vertical climb. Normally, a P-38 would begin to lose speed after 1,000 feet of vertical climb. But the propellers adjusted automatically, maintaining maximum efficiency. Lynch climbed 3,000 feet before needing to level off. Dick Bong discovered another advantage. In simulated combat, he could go from maximum to minimum power instantly. The propellers adjusted in fractions of a second, allowing maneuvers previously impossible. "It's like the plane reads my mind," Bong reported. "I think about accelerating, and it's already accelerating before I even finish pushing the throttle." March 18th, 1943. First real combat over France. 12 P-38s of the 55th Group intercepted a formation of 30 Bf-109s escorting Heinkel bombers. Oberleutnant Franz Stiegler, a German ace with 28 victories, saw the P-38s approaching and smiled. He knew the Lightning's limitations. Great in a straight line, poor in tight turns. "Achtung! Lightning approaching the sun. Standard defensive maneuver. Let's dance with them." But when the P-38s dove, something was wrong. They were going too fast, impossibly fast. Stiegler barely had time to shout a warning before Dick Bong sped past him at nearly 500 MPH, guns blazing. The Bf-109 to his right exploded. Stiegler pulled back sharply on the stick, expecting the Lightning to fly past, unable to keep up with the tight turn. But Lynch had figured out the trick. By reducing power on the inboard engine and maintaining full power on the outboard, with the propellers adjusting instantly, he could make the P-38 turn almost like a single-engine engine. Stiegler watched in horror as the Lightning impossibly kept up with him around the bend. "Was ist das?" he shouted as tracers passed inches from his cockpit. Within 15 minutes, 8 Bf-109s were going down in flames. No P-38s were lost. Stigler's report to the Luftwaffe High Command was alarming. The Americans have new Lightnings or modified existing ones. Estimated speed exceeds 500 mph in a dive. Acceleration and climbability dramatically improved. Our current tactics are obsolete. June 1944. Over Germany. Terror now had a sound. The high-pitched whine of Hamilton Standard propellers cutting through the air at speeds the Luftwaffe had thought impossible. Every American fighter, P-38 Lightnings, P-47 Thunderbolts, P-51 Mustangs, was now equipped with the improved hydromatic propellers. What had started as a 95 MPH advantage had grown. With continued refinements and better engine-propeller integration, American fighters were now 100–120 mph faster than their conventionally propelled counterparts. Major Walter "Bud" Heron, flying a P-47 Thunderbolt with the new 13-foot 2-inch Hamilton Standard paddle blade propeller, described the experience. "It's like strapping a rocket to your ass. Take off in half the distance, climb to 30,000 feet in under 7 minutes. Top speed 470 mm/p. The Jerrys just can't run." And the numbers were staggering and terrifying. Climb rate increased by 40%, takeoff distance reduced by 35%, maximum speed increased by 28%, range increased by 22% due to improved efficiency. Acceleration time from cruising speed to top speed reduced by 60%. General der Jagdflieger Adolf Galland, now commanding the entire Luftwaffe fighter force, wrote in his diary, "It's useless. Our Bf-109s and Fab-190s are technically equivalent to American fighters in basic design, but those damned automatic propellers give them an insurmountable advantage. It's as if every American plane had an engine 40% more powerful." Panic led to desperate decisions. Hitler ordered full production of the jet-powered Me-262, abandoning development of Piston fighters. But it was too late. For every Me-262 produced, the Americans produced 100 fighters with hydromatic propellers. A captured German pilot, Hauptmann Wilhelm Balthasar, told interrogators, "You don't understand psychological terror. You see a P-51 at 3,000 meters, a safe distance. You blink and it's on top of you. The acceleration is unnatural. It's like fighting something from another world." The sound became legendary. German pilots described the Hamilton howl, a unique, high-pitched howl produced by variable-angle propeller blades cutting through the air at extreme angles during maximum acceleration. "When you hear that sound," reported Oberfeldwebel Josef Zwernemann, "you have maybe 3 seconds before the bullets start flying, 3 seconds to say goodbye to life." April 15, 1945, over Berlin. The final aerial apocalypse. 1,200 American fighters, all equipped with Hamilton Standard propellers, escorted 800 bombers. The Luftwaffe managed to launch only 32 fighters in defense. Lieutenant Günther Rahl, flying one of the last operational Bf-109 K4s, described the moment. "It was like a mechanical anthill, P-51s everywhere, climbing, diving, accelerating in impossible directions. I tried to chase one, wide-open throttle, 380 mph. The Mustang just pulled away from me, as if I were standing still. It must have been doing 480, maybe 500 mph. At that moment, I knew the war was lost. Not just the battle, the war." Frank Caldwell's hydromatic propeller represented more than a technical advantage. It was the physical manifestation of a fundamentally American philosophy, the belief that ingenuity could overcome any obstacle, that automation could unleash human potential, that complexity was worthwhile if it produced simplicity for the end user. Colonel Charles Lindbergh, working as a civilian consultant in the Pacific, articulated this perfectly. The Caldwell propeller is democracy in mechanical form. It takes complex decisions away from the pilot, allowing him to focus on fighting and surviving. It is the antithesis of the Axis philosophy, which required superhuman pilots to compensate for inferior equipment. On the German side, frustration evolved into grudging admiration. Professor Kurt Tank, designer of the FW-190, admitted after the war, "We Germans focused on perfecting what we knew. More powerful engines, more aerodynamic fuselages, bigger weapons. The Americans reimagined the component everyone assumed was finished, the propeller. It was genius disguised as obviousness. But there was a deeper dimension. The hydromatic propeller required massive industrial infrastructure, precision factories, advanced metallurgy, complex hydraulic systems, and extensive training. Only the United States had the combination of resources, expertise, and production capacity to manufacture hundreds of thousands of these propellers. General Karl Spaatz, commander of U.S. strategic air forces in Europe, noted, "Every Hamilton Standard propeller was a statement. We have so much industrial capacity that we can afford to put a complex hydraulic system on every propeller of every airplane. It's psychological warfare through engineering." The production told the story. 1941, 2,000 hydromatic propellers produced. 1942, 15,000 produced. 1943, 45,000 produced. 1944, 85,000 produced. 1945 through August, 62,000 produced. Total, over 200,000 propellers, each a small miracle of engineering, mass-produced like nails. Frank Caldwell, now recognized as a national hero, remained characteristically modest. "I didn't do anything extraordinary. I just applied basic physics to an old problem. Any competent engineer could have done the same." But Admiral Mark Mitcher disagreed. Caldwell did something no military strategist could. He gave every American pilot a 100 MPH advantage. In aerial combat, speed is life. Caldwell saved more American lives than any general. Berlin, May 8, 1945. Luftwaffe headquarters in ruins. Hermann Goering, now a prisoner awaiting trial, sits with American interrogator Major Eugene Williams. On the table between them lies a single, twisted and charred Hamilton Standard propeller blade, recovered from a downed P-51. "You know," Goering touches the blade with fat fingers, "I laughed when I first heard about this propeller. Unnecessary complexity," I said. "Typical American waste." He pauses, his eyes lost in memories of skies he once dominated. "I didn't understand that you weren't building propellers. You were building force multipliers. Every mediocre pilot became good. Every good pilot became great. Every great pilot became invincible." Williams, himself a P-47 pilot, asks, "When did you realize you had underestimated the importance?" Goering ri amargamente. "When our aces started dying. Not rookies. Aces. Men with 50, 60 victories, being outpaced by American pilots with 10 hours of combat under their belts. That's when I knew we had lost not just technical superiority, but the very logic of aerial warfare." Hartford, Connecticut. Hamilton Standard Laboratories. September 2, 1945. Frank Caldwell sits in his office, the same one where he spent years developing the impossible propeller. On the walls are letters of thanks from pilots, thousands of them. "Dear Mr. Caldwell, your propeller saved me over Ploesti. Mr. Caldwell, I outclassed 3 Me-262s thanks to your invention. Frank, I took off from an aircraft carrier in half the normal distance." David Prince, now Associate Chief Engineer, comes in with the final numbers. "Frank, the statistical analysis is complete. Hydromatic-equipped aircraft had a 34% higher survival rate, a 67% higher victory rate, 18% lower fuel consumption." Caldwell nods silently, then walks to the window, looking out at the blue Connecticut sky. "You know what's ironic, David? I spent 5 years trying to make metal blades change angle. But the real angle I changed was the angle of war. We gave our pilots something no amount of training could, an absolute physical advantage. Tokyo, August 15th, 1945. Captain Saburo Sakai, Japan's greatest surviving ace with 64 victories, listens to the Emperor's surrender speech. Later, in his memoirs, he would write, "We fought with spirit, we fought with skill, we fought with superhuman courage. But how do you fight against mathematics and physics?" American propellers turned every P-51 into two planes, one to pursue, one to escape. It was technology transformed into inevitability. Epilogue, Smithsonian Air and Space Museum, Washington, D.C., September 15th, 1985. 45 years after Goering laughed at the impossible propeller, veterans gather for the dedication of a new exhibit. At the center, a perfectly preserved Hamilton Standard Hydromatic propeller, its polished blades reflecting the museum's lights. Frank Caldwell, now 94, frail but lucid, is helped to the podium by Dick Bong, Jr., a son of the late ace of aces. "They said it was impossible," Caldwell begins, his voice still clear. "They said it was too complex, too cumbersome, too unreliable." He pauses, his eyes scanning the crowd of veterans, many in wheelchairs, all wearing their unit caps. "But do you know what is truly impossible? Telling an American engineer that something cannot be done, telling an American pilot that he cannot fly faster, telling a free nation that it cannot turn physics into freedom." From the back of the crowd, a German veteran, Franz Stigler, now an American citizen and friend of many former adversaries, shouts, "Herr Caldwell, your propeller has haunted me in nightmares for 40 years." The crowd laughs. Caldwell smiles. "Sorry for the inconvenience, Franz, but we had a job to do." Stigler stands up, leaning on his cane. "Don't apologize. Your propeller taught me humility." Goering laughed when he first heard about it. He said physics doesn't bow to the dreams of engineers. He pauses, his voice carrying through the silent hall. He was wrong. Physics doesn't bow to dreams. But in the right hands, physics makes dreams come true. His propeller didn't defeat us with speed alone. It defeated us with the American idea that every problem has a solution, every limit can be overcome. Caldwell is helped down from the podium. As he passes the propeller on display, he stops, touching one of the blades with trembling hands. "Variable angle," he murmurs, "so simple in concept, so complex in execution, like freedom itself." Conclusion: Hermann Goering laughed in September 1940 when he learned of Frank Caldwell's impossible propeller. "Let the Americans spin their magic propellers," he toasted, confident of permanent German superiority. 5 years later, as the skies over Berlin darkened with 1,000 American fighters, each powered by propellers that defied his expectations, Goering understood his fatal arrogance. They laughed when Caldwell proposed blades that changed angle automatically. They laughed when the first prototypes exploded. They laughed when pilots didn't trust the complexity. They stopped laughing when P-38 Lightnings dove at 500 map. They stopped laughing when P-47 Thunderbolts rocketed overhead. They stopped laughing when P-51 Mustangs danced over Berlin. Frank Walker Caldwell didn't just invent a propeller. He codified superiority in metal and mathematics. Each blade that changed angle was a declaration. American ingenuity knows no bounds. 120 miles per hour, that was the advantage their propellers gave them. In aerial combat, where the difference between life and death is measured in seconds and feet, 120 MPH was the difference between empire and ashes. The propellers turned. Physics obeyed, the impossible became inevitable, and the sky, which Goering swore would always belong to Germany, became American, not by right of conquest, but by right of innovation. The thunder of Hamilton Standard propellers spoke on frequencies only defeat could hear, and when they fell silent, the world had changed forever.